what we'll do first is we'll just write a little program and just send an array of numbers to a function and print them out first, and then we'll move on to actually sorting. Okay. So hash include td_all.h. If you spot me making any mistakes, now be sure to point them out.
Should be the std for the default.
Very good. Now we'll make a character array. I'll just call it array for want of a better word. I think we said have up to 100 letters in it or something like that, wasn't it? Oh yeah, it's numbers, wasn't it? It was a numbers one, yeah. So it's an int. So we could have up to 100 numbers in it, and we may as well generate those randomly because it's and we can generate different lengths of them, but we'll generate that. I'll make a few I'll make an int I as well. We're likely to need that at some point along the way. So what I'll do, yeah. So we'll use a for loop. I signed 0. I smaller than 100.
You're not going to ask.
Oh yes, for any particular size, isn't that right? So I should really ask for a number first. So that's a good point. I did say in the specification that you could have any size. Now, obviously, we're going to set a limit of 100, but we'll say any size. So what I'll do is I'll do a printf, and I'll do a little size up here, int size.
Can you do a space after printf?
You could, yeah. It wouldn't normally be okay, but yeah, you could as far as I know. So printf, enter the size of the array. Okay, smash in. So we'll need a scanf then for that, won't we? Yep. %d. What have I forgotten there? That's right. And ampersand size. So put that size in there.
Oh, that's bigger. Someone said it's bigger than 100.
Well, we're not going to for the minute. Obviously, we're just setting an upper limit on it. The reality is that if we want to have something that can go up to any number, we should really have a malloc in there to actually allocate the memory rather than doing it where we just put in 100. But we'll keep it simple for the minute. So I++. Now, can anyone remember how I put in random numbers? So array.
Sorry, array I equal to.
Yeah.
Then 2 brackets.
2 brackets. We keep it between any. We keep it between. Yeah. So what does the percentage mean? Can you remember? Yeah, it's the modulus. So will we keep between 0 and 20 maybe? So how would I do that? Modulus 20, exactly. Right. Okay, so that'll fill up the array. And what we should do, try not to bite off more than you can chew at first. So always maybe write in a little extra line of code if you need it. We'll just print this out now and just check that it's definitely giving us those numbers. So what I'll do is I'll actually put it in the for loop with it.
Yeah.
That's going to print out one after the other.
Yeah, so but what I'll do is it won't print them in order, and it'll print them as it's generating them. And what I'll do is I'll also put a space between them just to make sure. So %d space. I won't bother putting them on a new line. It's a bit too much hassle. And just to check that it's happening the right number of times, what I'm going to do is I'm going to put I here as well. That's true. I'll come back to that in a second. What I'm going to do is I'm going to do a %d. So I am actually going to put them on a new line now, just so that I know, okay, that's how many of them I've done to make sure my size is working correctly. Okay, and as Frank says, put a semicolon there. So what do I normally put after scanf just to make myself safe? Get char. another one here. TURN 0. I'm hitting the end instead of the deletion. I was wondering why it wasn't operating. So I need to save this as something. I won't save it on the desktop. It's probably not the best idea. So I'll put it inside in my H drive. H drive. There we go. cprogs, and I'll give it a name like sort func because it's going to be a function for sorting numbers, and that's right. And put it as a .c. So click on that. That'll do it. So now it's up as a sort func.c. We'll give it a run there, see if there are any problems that we haven't spotted, and it's certainly running okay. Enter the size of the array. We'll pick something small like 13, and we've gone here from 0 up to 12, which is 13 numbers, and all those numbers, as we can clearly see there, are between 0 and 20. So that's working pretty okay, right?
Well, is everything zeros random number?
Oh yeah, there's no reason why not.
Why are you using 2%
Just to run it again there, the reason we're using 2% is if I type in 14 here, it gives me the 0, 1, 2, 3 all the way up to 13, so that I know which number I'm on, which number, and then this is my random number that I've created. Okay, so that's working pretty okay. Now what I'm going to do is we'll get rid of that, delete there, and we'll call our function. Now we'll need to make our function first. So I'm going to write it up here. First of all, give me the basic. Okay. Do we need to return anything from this? Yeah. So we don't. Right. So void. We might find later there might be a reason to do so, but for the minute we leave it as void. What do we call it? Sort. What are we sending to it? An array. So an array of integers. Integers. Okay. And I'll just call it, well, call it array, even though I know it's the same name as the other one, but it's probably fine. What else do we have sent? Size of it. Int size. Again, I could call them different names than I'm using there in the program, but that's really all that matters, yeah. So we'll do that there. Again, get rid of the semicolon this time, because now we're going to actually write the proper function. Now,
Do you need an int main void in that array? You need it in the top.
do I need int main void in this? No, definitely not. You only have one main.
Yeah, but are you not going to get rid of that int main void? No?
Am I?
Are you not going to get rid of that int main?
No, I'm not. No. This is separate to that. That's my main function. This is just mentioning it. It's got a semicolon there. Declaration, exactly. You're using the right terms and I'm not. Now, I'm just going to put it like that for the minute. I'm fairly certain that works. We could also put it in as a int asterisk array, which would be a pointer to an integer, which will work the same, right? Now I know, Seamus, you haven't seen that yet, but that's fine for the minute. And now we need to sort it. Now going through the sort, the sort algorithm again. I'm trying to think my way back. Which did you use? Did you use the swap sort or the bubble sort? Or
We don't know what's two of them.
I know you did both. But which were you using in this one when you went at it? Would you have a preference for one? I can't remember which one turned out quicker. One of them I think was a bit. Was the bubble turned out quicker? Okay. So I think it had two for loops if I'm not mistaken. So int I and int j. And we have for loop that's going to go I sign 0, I smaller than size, I plus plus. And with another for loop inside that, for I not well spotted. If we all had 4 people looking over our shoulder, we'd be great programmers, wouldn't we? Okay, so J, did you question there, Frank? No.
Note the int size.
Yes.
You're going to make that point to 1,000.
No, I won't actually have to, because I don't have to return anything with the size. I just need to use it. Okay. The array, though, the point about the array is that the array is actually passed as a pointer, and so therefore any changes I make to it inside the function will reflect outside, and I don't have to return it. Okay. Now, I don't think I started. I'm trying to remember the bubble sort now. Which way did we do it again? Have you got it there? If you have, it'll make it easier rather than me trying to figure it out as I go, because this will take time. That's okay. What have you? What I'll do is I'll just we'll set the thing going there, recording again. J is assigned 0. J is smaller than size. Size. J plus plus.
Then you have an if statement.
Alright now. So then I have an if.
If array I is greater than array I plus 1.
The different names make it difficult, alright, yeah, but that's okay.
No, if I temp equal to array I, just another integer, I think.
Oh, so we need to make another, yeah, because we're doing a swap here, as such.
Temporary.
So int temp.
Temp equals array I.
Is assigned array I. Then
array I is equal to
Array I plus 1.
yeah.
I plus 1.
And then array I plus 1 is equal to 10.
okay, and is that pretty much it? There's nothing else. There's nothing outside that if statement, is there? So that's pretty much it. Okay. Now, what I'm going to do is I'm going to I want to call that function up here, right? So I call it and it says sort, and I send it array, and I send it size. And then I do a printf. Sorry, I do a for loop. For loop.
That one I went through then, that is the bubble, isn't it?
I have a feeling, yeah, I have a feeling that's the bubble. I'd have to think about it in detail, but I'm fairly certain it is. Of course, both the bubble and the swap actually swap things, so we're getting a bit confused with that. But so for I signed 0, I smaller than size. Be nice if I could use this for loop up above it. If I could use this for loop again, but I can't because I have to do the sort in between. So that's why we can't put the two things into one. Exactly, yes. You have to have two separate for loops, even though they're identical to each other. They're done at different times, and that's what's important. So we do a printf. Oh, here, and I'm going to do the two of them again, Kelvin. %d new line I and comma and array I. Yeah.
I always get confused, like, you know, when you're passing them to the function, I always think you have to have a different name on them and that, you know.
You don't have to at all. So sometimes it might make more sense to have a different name on it, but in fact you don't generally, right? So let's take a run at this. I wouldn't be definite that this will run first time, but we'll see how we go. I've obviously put in an extra little semicolon there, so just shouldn't have. Just check that now for definite. This is where the indentation comes in. Good. You can see that one there, and we can see that one there, and then this one here goes down to that. Should be okay, I think now. Indentation wise, anyway. And, enter the size of the required array. Let's go for 14. Now, and then it's done a printout and it said 1, 7, 14, 0, 9. It certainly hasn't sorted them by the looks of it. Okay. I also don't like that number there that's sitting in the middle of it. Right? So what I'm going to do is I'm going to quickly pause the video until we can spot there again. Okay, so just for watching the recording to point out the two mistakes. Because of the way I have the for loop, I used I in my first one and J in my second one. J should have been used in all these places along here instead of I. Previously it was I. And the second thing that I've done is, when we got up to J smaller than size, let's say our size was 14, J would be 13, okay? Now, in an array, you'd only be going from 0 to 13, so when I say J plus 1 here, I'm immediately going on to number 14, so that's a problem. So what I've done is I've said, while it's smaller than size minus 1, just to make sure we don't go any further than that, okay? I thought we had solved that, that's why I'm wondering when I look at the problems that it's not there, but I want to have another look at yours, trying to see is there some other way that we've written it to get around the same problem. Now, I'm going to take that out of there, right? And I'm going to take this out of here. So that now what I do is I print out, after my array, I'm going to do a print out here to show, and I'm going to say printf, printf before sorting. In, like that, and then I'm going to after the sort, I'm going to put it in here as after sorting. Okay. Pick a smaller array this time, maybe 7. So we can see that they're not in order here, but after sorting they are in order. Okay, and you can see the point of doing that printf. Those ones there. So you've that one there, and then you've this one here, and they're before and after the sort. There is no printf in the sort itself. Okay, but clearly it's the one doing the sorting, and it has an effect outside of its own function because of the fact that you're using a pointer. Yeah. Now there's no way of sending an array where you actually copy all the stuff over, so when you send arrays it has to be as a pointer. Now do you see the way I have the asterisks in there, right? You can use this type as well, okay, because in effect they mean the same thing. Okay, so if you're more used to that, in fact I would actually advise when you're sending an array or something like that, that you're better to actually use that notation there than the pointer, because you know it's an array, whereas the other one, it may be a pointer to one integer, it could be a pointer to 20. So at least this way, you know how many you're sending. You don't have to say how big it is, but if we try putting in 20 there and 20, or let's say 100, sorry. Now this isn't a great idea because our size should tell us that. That 100 should have absolutely no effect, but it might be useful for the person who's reading the program later to realize that it's 100 in size. Okay. But in general, I wouldn't be too concerned about that bit of it. It's mainly just to say that it's an array. Okay. Is that okay? I know you had a bit of trouble with this one, did you?
Yeah. And it's very simple.
Yeah, it's not too bad. But it's like all these things. Once you know how to do it, it's fairly simple. When you don't, it can be quite complex. You know. Are you happy enough with that? Do you follow how it's done? Yeah. Nothing too bad about it. Okay, so we'll hit.